Hi, I'm Dr. Philip Macmillan, and thank you for joining me as I continue to dissect the implications of what is happening in the pandemic. Well, some people would say it's an epidemic in highly vaccinated regions. They're probably correct. But a lot of people get carried away by the fact that infection is quite mild at the moment. So intensive cares are not full. You're not seeing lots of people on oxygen in hospitals. And so therefore the perception is that COVID is largely over and it's just a mild cold. I understand that sentiment, but if you follow the science, you will realize that this is far more serious than anything we can imagine. I'm going to explain to you quite simply why I say that. As usual, I have this COVID storm iceberg. I've used this example for a while, where even though symptoms may seem mild initially, they can oftentimes be associated with quite a lot of abnormal patterns subsequently. And this is the bit that people don't quite understand. So I'm trying to find ways to make it make sense. And one of the things is that today I'm going to focus a little bit on the endothelium and just a few slides to help you to understand what I'm thinking about and why I think this is very relevant. Before I start, just a quick reminder for all the people who want to learn more about what is going on in terms of the changes. Remember to join us here. Oops, sorry, let's just get rid of that. Remember to join us at this conference, Hidden Drivers of Post-COVID Dysfunction, Mitochondria, Microclots, and Microbiome Imbalance. This is a very, very important piece of work, and we're getting experts from across the world to try and see if we can understand what in the world is going on and why so many people are still so sick. So let's get back to the science, and I will give you an idea as to where I think that we need to focus our attention. So I was talking about the endothelium. This is what it looks like in a blood vessel. This is a slightly bigger blood vessel, but the principle is the same. What I want you to focus on is the inside here. This is called the endothelium. It's the lining inside the artery. Don't worry too much about the muscle around or the vasa vasorum around the adventitia and so on, or the elastic membrane. Just concentrate on this endothelium. It's very smooth, and it has to be because the blood is set up in such a way that any abnormality in this will trigger it to start making clots to keep it very, very smooth. And so that's the basis of what it looks like with the endothelium. When you look at it in more detail in smaller blood vessels, this is what it would look like. And critically, now you can see not just the cells, but the glycocalyx. This beautiful little furry area here, right on the surface of the cells. And you can see here that it's about zero point 0.2 micrometers in depth. And it's like hairs on the surface of the endothelium, kind of like the hairs that are on the surface of your skin. They're not so visible unless you really zone in on it and take a really good look. And that glycocalyx is very, very important. Here's another image that helps you to get the idea of it here. And in this paper here from glycocalyx sodium interaction in vascular endothelium, again, you can see at the top here is the blood vessel. And they're kind of making it look bigger so that you grasp what it looks like. And these are the red blood cells, white blood cells, and so on. But you can see now this hairy-like structure is composed of proteoglycans, syndecan 3, CD44, and they're all there to help to protect the endothelial cell below. And this glycocalyx can become damaged. And when it gets damaged, this is when it starts to cause problems because the glycocalyx has a number of very, very important functions. It's again barrier function. So it regulates permeability. So it prevents fluid from leaking out of the blood vessel, which you don't want unless it's a capillary. It's against inflammation, and it shields the cells below from white blood cells attacking them. It also prevents clotting by, again, protecting the surface of the endothelium from interacting with proteins that cause clots. Additionally, because in arteries there's so much pressure, it helps to protect them from being damaged. And critically, it facilitates nitric oxide production, which helps to keep them dilated and maintain the blood pressure. So this glycocalyx is an essential part of vascular health. And you may be thinking to yourself, why are we talking about it now? And what is the connection with COVID? Well, the simple connection is just to do with the spike protein. What we know, and this is another paper here, SARS-CoV-2 and the spike protein in endotheliopathy. You can see here it's showing that the virus, primarily through the spike protein, can interact with specific proteins on the surface of these endothelial cells. This is where it would bind to ACE2. It then causes cytokine release. And all of this, it damages specific parts of the endothelium because it causes it to become degraded. And then suddenly the hairs start to fall off and you get these little potholes in the surface. And this is my analogy when I'll be showing you what I think it's like in terms of the blood vessels. Now, remember, the spike protein circulates and lights up most of the vascular system. A lot of people think that the main problem with COVID is viral replication. No, it's about that spike protein literally damaging the vascular endothelium and certainly in severe COVID causing microclots. And this is what it could look like when they looked at what happened with where spike protein went after you injected it. You can see in influenza it stays in the lungs, but goodness, when they inject it inside the mouse hair, it literally spreads everywhere. Brain, heart, kidneys, intestines, all the blood vessels throughout the body. It is definitely a vascular target, this spike protein. And this is why people need to be so careful no matter how mild symptoms are. Your best protection is to prevent spike protein getting into your vascular system. That's the premise. Mucosal immunity at all costs. Nitric oxide, hum away. Please reduce the risk. Here is another image from that paper in terms of the damage. And you can see here that the spike protein interacts with ACE2. It will interact with fibrinogen and thrombin, and it damages the mitochondria, which can then lead to particular pathways of clotting. And the more that I speak about clotting, we have to realize that many of the clotting mechanisms that we are looking at are now probably linked to the fact that spike protein is damaging and contributing to a hypercoagulable state. Here is my analogy as to what's happening. Even though infection may seem mild, if it has broken through your mucosal barrier, and this is where the difference, I think, exists between the cohorts of vaccinated and unvaccinated people, is that it's much less likely to happen in the unvaccinated. If and when it breaks through, even if symptoms are mild, this is what I predict is happening. It's damaging the asphalt on the surface of the roads. And this is how it would end up looking. These potholes, imagine, scattered through all the blood vessels. And then when the immune system comes along, it tries to patch them. As it patches them, it makes these little clots. Some of them break off and then they continue to blow down the road. This is the pattern that I think is happening even silently. Vascular endothelial damage is very similar to what would happen in the asphalt on a road. Just imagine what it would look like if there was no healing and we continued to drive on those roads causing damage. Remember, let us be wise about what is happening. This endothelial glycocalyx Very, very important. And we know spike protein damages it. Once it's damaged, and then there is exposure of the endothelium, that leads to many chronic illnesses. And therefore, we have to find ways to manage it. So, if you want to learn more about what is going on, please look in the description below. Join us for our conference coming up because we'll be focusing on this kind of pattern. Tickets are free. We're happy to have donations to support us, but let us see if we can prepare for the future of disease, because when it comes, it's not going to be as people think. It's not going to be severe COVID, but it's going to be more like what I said, that COVID iceberg, that storm of chronic immune symptoms tied in with vascular damage that will be doing all of the problem. Everybody needs to be prepared. Let's see if we can find ways to protect each other. Have a great evening.